Hello and welcome back. Today we've got a very exciting tutorial. We're talking about the S3 consistency model. Let's dive straight into it. Okay, so consistency model. First, we'll talk about what is the problem that it solves. Well, imagine you have a distributed system with a database and a replica of that database. And users can read your data from either the main database or the replica. And inside these inside the system, you have a file. You store it. You already have this file stored. It's already been replicated into the replica. Great. Now what you're doing is you want to update the version of this file. You're uploading version 2, overriding the original file with this version 2. So it gets updated in the original database, and then it gets sent to the replica for replication. But that takes a couple of seconds. In the meantime, a user wants to access that file from the replica. And the question is, what will they get? Will they get the original file, version 1, or will the replica wait a little bit until the file is updated and give them version 2? So what will the user get, version 1 or version 2, if it happens that they're accessing it in exactly that time when it's being updated to version 2? So that's the problem that consistency models are created to solve. And there's two main ways that they go about it. The first approach is eventual consistency. And in this case, the user will get a lightning fast response, but they possibly will get stale data. So in this case, they'll get the version 1 of the file. There will be no delay. The system won't wait for the updated file to come across. And in some cases, this can be useful. So for example, imagine you're requesting a video from a YouTube server. And as part of the video, as part of the request, what you will get is the number of likes in that video. Well, you don't really care about the exact number of likes. Is it 693 likes or is it 695 likes? Maybe in that time when you sent the request, maybe a few other users have liked that video, but it doesn't really matter to you that much if there's 2 extra likes, if the data isn't exactly correct. What does matter is you want the response fast. You don't want to have to wait for 5 seconds or 10 seconds or 3 seconds for the YouTube video to load. So in this case, a fast response is more important for you than the correctness of the data. In some applications, strong consistency is more important, and that is the other approach. Strong consistency is when you possibly get a delayed response. You might have to wait a couple of seconds for the response, but you are guaranteed to get up-to-date data. An example of such application is when you're requesting stock prices from the stock market. You definitely want the correct prices, right? So if the price is $109 for the stock you're interested in, you want to make sure you're getting that $109 and not 107 or 123 or whatever it was a few seconds ago. You're okay to wait for the update. So you're okay to wait a few seconds for the price to be, for the correct price to be found and given to you, but you want to make sure it's correct. So in this case, correctness of data is more important than speed for you. So that's a trade-off. These consistency models, they trade off speed, how quickly will you get the response, versus correctness of data. How okay are you with getting stale data, or do you want guaranteed up-to-date data? So in one case, you'd use eventual consistency, in the other case, strong consistency. So the question is, what about S3? Well, in S3, we know that data is replicated. So we have replication across servers in one availability zone for durability. And we also have a replication across availability zones for high availability. So we're facing that problem of a distributed system, and which consistency model does AWS select? Well, AWS for a long time had eventual consistency, and you had to come up with your own ways to ensure the data is correct and come up with systems that control that. Well, good news is that after a certain point in time, AWS switched, and now they guarantee that S3 data within each region, this is important, not across regions, but within each region, S3 data is strongly consistent. So you don't have to worry about it. You are guaranteed by the AWS that data will be strongly consistent within each region. And that applies to, this replication within one AZ, replication across AZs. And that is great news. That means we know and which model it is, and we know it's a strongly consistent model. So it removes a lot of headache. So there we go. That's what strong consistency is all about. Here's a quick summary of what we discussed. Remember for the exam that AWS S3 is strongly consistent. I look forward to seeing you back here for the next tutorial. And until then, enjoy the cloud.